Look at this isolated subject in the center of the frame. Two people can take the exact same dose of cannabis from the exact same plant and have completely opposing experiences. One person locks into a state of extreme, euphoric creative focus, while the other becomes entirely still, paralyzed by crippling paranoia. This intense unpredictability happens because cannabis does not play by the standard rules of brain chemistry. When you observe how dopamine, nicotine, or alcohol operate, they have generally reliable pathways. Cannabis ignores those pathways entirely. From the moment you inhale or ingest it, the active compounds need only 30 seconds to enter the bloodstream and achieve total saturation of the brain. To make sense of the high, we have to stop thinking of cannabis as a standard drug with predictable side effects and look at exactly how it executes a highly coordinated biological hijacking. The success of that 30-second breach comes down to a specific biological trait. The active molecules in cannabis, like THC and CBD, are highly lipophilic, meaning they have a chemical affinity for fat. You can see what that means in this cross-section diagram of a neuron. Every cell in your nervous system is protected by a double-layer lipid membrane, a barrier of fat. Because THC is lipophilic, it dissolves into the cell, flowing directly through the fatty membrane rather than waiting at a surface-level gateway. And once it's inside, it likes to stay there. This same diagram scaled out shows how those molecules seek out deep visceral fat around your organs and lock themselves in. They can remain biologically active and detectable in these tissues for up to 80 days after a single use. That deep tissue embedding is exactly why the popular idea that you can simply sweat the drug out in a sauna or quickly burn it off by losing body fat is categorically false. By effortlessly bypassing our normal cellular defenses and taking up long-term residence in our tissues, THC secures unchecked access to the master communication circuitry of the human brain. Once inside the brain, the THC molecule seeks out a very specific target, the CB1 receptor. These receptors are densely packed across almost every neural circuit we have. When THC binds to these receptors, it triggers the bizarre communication method that defines our endocannabinoid system, a process called retrograde signaling. Normally, signals flow strictly forward across the synapse, but THC forces a glowing signal entirely backward, commanding the sending cell. As this diagram splits, you'll see these identical backward commands trigger entirely opposite reactions, depending on where they land. Up in the prefrontal cortex, the area right behind your forehead, the backward signal acts as an accelerator. It increases chemical transmission, which intensely narrows your focus and elevates your mood. But down in the amygdala, the exact same THC molecule, binding to the exact same CB1 receptors, acts as a brake. The backward signal decreases transmission, successfully quieting the brain's main threat detection center. We are left with a chemical that cannot be categorized as a simple stimulant or a basic depressant. It operates as a localized dial, simultaneously pushing one part of the brain into hyperfocus, while actively suppressing the physical capacity to feel fear. But the prefrontal cortex and the amygdala aren't the only regions catching these backward signals. The extreme density of CB1 receptors means secondary brain systems are heavily caught in the crossfire. In the hippocampus, electrical activity is severely suppressed. Because this region governs memory processing, the immediate biological result is a deficit in short-term recall. At the exact same time, activity in the basal ganglia is forced into a similar decline. This is the circuitry responsible for action planning and physical movement, directly leading to the heavy physical immobility often called couch lock. Yet, while those systems shut down, the hypothalamus is thrown into hyperstimulation. This overactive hypothalamus creates a two-pronged attack on your appetite. It generates an intense cognitive fixation on the taste of food, while simultaneously firing signals down to the gut to physically alter your blood sugar levels. The combination of memory loss, heavy physical immobility, and intense appetite signals creates a chaotic, system-wide override. Because these receptors are scattered indiscriminately across so many competing neural circuits, the delicate balance between the accelerator and the brake is prone to severe glitches. When that biological glitch occurs, the intended relaxing effects vanish. Instead, the brain is flooded with intense anxiety and sudden paranoia. You might hear dorm room lore claiming that naturally anxious people are more prone to these bad reactions, but the clinical reality is that your baseline sober anxiety levels cannot predict how you will react under the influence. Even more dangerous is the persistent advice that smoking or ingesting a higher dose will magically push you through the paranoia and mellow you out. THC and CBD potentiate the pathways they bind to, meaning taking more of the drug will only multiply the anxiety. Look at this modern apothecary display with its perfectly identical glass vials. The modern cannabis industry relies on imagery like this to sell the promise of a sterile, highly predictable, perfectly customized high. But there is no physical trait, not your height, not your weight, not your genetics, that can guarantee how a specific strain will navigate the unique layout of your individual neurochemistry. Despite the massive commercial effort to tame and package the high, cannabis relies on retrograde signals that jump backward across synapses in completely opposite ways. It remains a chaotic biological hacker, rewiring the brain's communication network in ways we can trigger but never truly control.